Hey everyone, this is Ed, and in this video I want to cover how to use the CTRE Swerve Generator. Now this Swerve Generator is built into TunerX, which is the program you use to configure all your CTRE devices. And it's super awesome because all you have to do is enter your wheel size, the distance between your modules, select your swerve drive unit, and type and ratio, and what it'll do is it'll allow you to configure all your devices correctly and generate code that works out of the box with basically zero changes. The first time I did this, I didn't have any swerve experience, and I think it took me about an hour to do. Now that I've done this a few times and had some practice, I can get a swerve drive running in about 20 minutes using this tool. So it's super awesome, and I'm going to show you how to use it today. To get started, the first thing we're going to do is actually to launch TunerX. I've got that pinned on my taskbar here. So go ahead and launch that. You see, right now, it's not finding any devices because I'm not connected to my robot and it's not turned on. So the first thing I'm going to do is turn on my robot. And while that's booting up, what I'm going to do is go to the hamburger menu on the left here, and we're going to change this to driver station. So naturally, next I have to launch the driver station. So I'll go ahead and do that. And give it a minute to launch up here. My driver station is launched, my robot is turning on, so I'll make sure that I connect to its Wi-Fi once that pops up. There's my Wi-Fi, I'll click connect. And you see we now have COM and code, and now we see devices actually show up in TunerX. Now the first thing we're going to do is make sure everything is up to date. So to do that, I'm going to hit this box up here. That changes it to list view. I'll click this double check mark. That's going to select all my devices. Then I'm going to click this arrow here to upgrade all of them. I recommend you use Phoenix 6 and whatever the latest version is, and go ahead and hit upgrade. And this is going to take a few minutes, so we'll let this run. Okay, that completed, and it took about 3 to 4 minutes here. So you see all our devices are updated. We'll click OK. I'll close out of that. I'll go back to my block view. And you see all my devices are green, and that's good. Now the next thing I really recommend you do is to group devices into modules and assign their CAN IDs and names accordingly. What do I mean by that? Let's go over to the robot. So on this robot I have 4 swerve modules. This is module 1, this is module 2, this is module 3, and this is module 4. Now where your mod 1, 2, 3, 4 on the robot is doesn't matter so much as that when we group our motors and CAN coders together, they're all on the same module. This is going to make identifying them in our list of items a lot simpler. For example, on module 1, my drive motor is device 11. My turn motor is device 12, and my CAN coder is device 13. On module 2, my drive motor will be 21. My steer motor will be 22, and my CAN coder will be 23. So on with module 3, I'll have drive as 31, steer as 32, and CAN coder as 33. And on module 4, I'll have drive as 41, steer as 42, CAN coder as 43. So what I'll do next is I'll show you how to assign device IDs and names in TunerX. What you can do is click on any device. You see additional detail pops up. You can edit the name here, so I could say mod, I don't know, for example, 5 drive. And I click set. I hear the motor chirp, and I can say this is device ID 51. Hit set. The motor chirps. We go back to our list and we see this device is now renamed. If you have a bunch of random motors that from a drawer, you may need to take some time and make sure all of these are grouped in a way that makes sense. So with all our devices grouped, we are now going to jump into the generator. So we go to the hamburger menu, click on mechanisms, and now taking a look at our checklist, we need to make sure we have 8 motors that are Talon or Talon FX. If you're using Krakens or Falcons, those are Talon FXs. The Talon FXS is used to control minions or Neos on the CTRE motor driver. We also need a pigeon. With that done, the next thing I'm going to do is enter the math for our modules. Now, I happen to know we have 4-inch wheels, so the radius of 4 inches is 2. And next what I'm going to do is measure the distance between my modules on my robot. And that's going to be the distance center to center on your swerve wheels. Now to show you what the measurement I'm actually taking is, I want to get the center of this wheel to the center of that wheel. And I could eyeball that, but I think it's actually easiest to take the edge of the tape measure and hook it on that far left edge there. And then we measure to the far left edge of this wheel. And when I do that, I'm reading about 14 3/4. And for this application, plus or minus a quarter inch is probably sufficient to get you up and running. I have a square robot, so I'm going to enter the same number for both directions. So I have 14.75 is 14 3/4. Enter that for both of these. Next, my swerve modules are Swerve Drive Specialty. I'm running MK4I on this robot, and our drive ratio is L1. And next, what we're going to do is click New Project. And I guess I forgot to check this box. Yes, we are using all CAN coders in our case. And now we're into the meat of the Swerve Generator. Now, to configure our modules, what we're going to do is basically in every section here, we're going to select our module. We're going to tell it what our turn and drive motors are and which CAN coder it's using. We'll then blink those devices to make sure they're correct. And then a little validation button will pop up and we'll make sure that's all good. To start, we'll do front and left, which my notes tell me is module 3. So I'll do mod 3 steer, mod 3 drive, select CAN coder, and mod 3 CAN coder. And what I'll do now is I'll blink each of these devices, and I'll show you what that looks like. All right, I'm going to blink the CAN coder first, so we should see that this light will turn orange. Blink. See, it's turned orange. Next, we'll do the turn motor. I'll click blink on the turn motor. We see that's blinking fast, so that's good. And our drive motor is on the opposite side here. It's going to be covered by a box, so I'll skip that for now. Next, what we'll do is we'll click validate. And I encourage you to read this, but what we're going to do is enable the driver station, and we'll click azimuth test. And what we want to see is the swerve drive turning. After that, we'll click start drive test, and we'll see the swerve wheel drive. So what I'll do is I'll click on my driver station, I'll click enable, I'm going to click start azimuth test, and I'll show you what this looks like. Okay, my robot's enabled. I'm going to click start azimuth test. And click continue. And you see our swerve drive is turning, and this is what we want to see. What's happening is the swerve generator is making sure that the turn motor and CAN coder are correct. Next, we'll click start drive test, click continue. And you see our swerve module is driving, and this is what we want to see. We'll let that finish. Always let it finish. Do not stop it early. And with both of those done, I'll go to the driver station. I'll click disable. I'll click on validation complete. And you see this one is no longer highlighted. That means it's good to go. So next we'll do the front right. My notes tell me that that is module 2. So I'll go mod 2 steer, mod 2 drive, CAN coder 2. Validate. I'll enable, blink blink, start azimuth, continue. And I see this module is turning, so that's good. We'll let that finish. Good. Next we'll click drive, continue. I see it's driving. We'll let that finish. Perfect. Disable. Complete. Next, back left, is my mod 4. Turning motor, mod 4 turn. Drive motor, mod 4 drive. CAN coder 4. I'll blink that CAN coder real quick. That looks good. I'll press enable on the driver station, validate, start azimuth, continue. And my swerve module is rotating, which is what I want. We'll let that finish up. I'll click start drive test. And it is driving, so that's good. We'll let that finish. Perfect. Disable the driver station. Validation complete. Final module back right is mod 1. A really cool thing about this GUI is if I select the wrong motor, for example, you see, hey, we get a little warning here. It says this device has already been used. So it's going to catch our errors as we go, which is awesome. So we'll click mod 1 steer, mod 1 drive, CAN coder 1, and validate. Enable in the driver station, start azimuth, continue. And my module is turning, so that's good. We'll let it finish. Cool. I'll do drive next. Perfect. Okay, those are all good. I'll click complete. I'll disable. Okay, now that all our modules are configured here, the next thing we're going to do is to calibrate our encoders. So we'll click calibrate, and I'm going to recommend you read this. It's important that we disable the robot. And next, what it's going to ask us to do is to rotate all our wheels so the bevel gear is on the inside of the robot. So on the right-hand side, the bevel gear should be pointing this way. And on the left-hand side, the bevel gear should be pointing that way. So both sets of bevel gear should be towards the inside of the robot. Once that's done, we'll take a nice straight edge and align the wheels using that straight edge. 1x2 tubing works great for this. We'll click next, and when we're all done, we'll click Calibrate Encoders. So I'll show you what that looks like, and then we'll click Calibrate.
So what this is actually asking us to do is to take our modules and rotate it so this bevel gear is pointing inward on the robot, and pointing inwards this way for this other side of the robot. Then what we should do is take a straight edge like this and push it up against those factory edges on the wheel and hold it there nice and firm, and that'll make sure my wheels are nice and straight. I'll do that on this side as well. There's my bevel gear, rotate inwards. There's my bevel gear, rotate inwards. I'll grab my straight edge, line up my wheels. So now all my wheels on both sides are nice and straight with the forward direction of the robot.
Now that you've seen the process of aligning those wheels, we'll go ahead and click Calibrate. This will pause for a moment. It says successfully calibrated all encoders. Great. We'll click I'm finished. All right, our final step is verification. So we'll click this here. So verification comes in 2 steps. We first verify the steer, and then we verify the drive. Let's click on steer first. I encourage you to read all of this, but essentially what's going to happen is it's going to rotate all of our wheels. And we want to make sure that they are rotating in the correct direction. Now when we're doing this, it does want us to have the robot up off the floor so all the wheels can rotate freely. As you can see, I've got my robot on big box, but essentially we want all the wheels to be fully free so they can rotate and turn without catching on anything. I'll go ahead and enable in the driver's station. You see blink blink, robot's enabled. I'll click on start. What we're seeing now is all these wheels should be rotating. And what I was seeing is they're rotating like in this direction. So if I'm looking from the top of the robot, they're rotating clockwise. And when I read my text here, it says, did all modules rotate counterclockwise as seen from the top of the robot? I saw no. So what I'll do is I'll say this one was not going correct, nor this one, nor this one, nor this one. I'll click rerun, and I'll also show you what that looks like from a separate camera here. I'll click rerun test, and I'll click start. Chirp, chirp, chirp. You see all our wheels are rotating. Now I'm going to run this again because I didn't actually look at every wheel, but I saw at least my left side looks good. I'll move over so I can see the right side next. Click rerun. I'll click start. That one's rotating this way, this way, this way, and this way. So if I'm looking from the top of the robot, they are all rotating counterclockwise. I read my text here. Did all motors rotate counterclockwise? If so, click yes. Good. See, this is now done. We have a green circle here. We'll go back to verification. And next we're going to click drive. And again, I encourage you to read all of this. But what's going to happen is it's going to turn all the wheels to be in the straight direction, and we should see the robot move forward. So we'll click start. You hear a lot of chirping. And what I'm going to do is gently feel and look that all our wheels are in fact aligned. And when I gently feel these wheels, I feel that they are pushing the robot forward.
which is what we want.
I see a box here. Average velocity was number. Did the robot move forward? Yes. Test complete. Okay. And what I'll do is I'm going to disable the robot, and I'll show you that from another camera angle. So here's another view of what's happening under the robot. I'll click start. I click start. We hear all the motors chirp. Those wheels are going to turn and align. And then we should see them start to drive, which we do. And if I gently feel this wheel, you see it's pushing my hand backwards, which means the robot is going forwards like that. After our test, we'll click disable on the driver station. We'll go back to verification, and we see green text, we're done. Now that our verification is complete, you see we have two options here. We can generate a project or only the tuner constants. The project's going to generate all the code, all the backend, all the infrastructure needed to drive this robot, versus only tuner constants will generate the single file that defines just our Swerve drive. So what I'll do here is generate project, enter my team number, I'll click OK. You see 3 languages are supported, Java, C++, and Python. If you're on LabVIEW, I'm sorry. We'll click Java, and next we'll create a folder for this project. Create a folder there, select folder, and this other box will pop up. All I'm going to do is open project in VS Code. And now, if you're familiar with programming, this should be fairly familiar to you. We have our code files here. Now, if I go to SRC, main, Java, generated, I'll click on tuner constants so we can take a brief look through there. This is the one file that contains everything unique about this chassis. All the modules, all their settings, and all that is defined here in tuner constants. You can generate your code at the start of the season using a test chassis, and then later in the season, you can click just generate this tuner constants and replace this file when you have a different chassis, if you have a different chassis. And a few things I recommend you change right off the bat, or at least that I like to change off the bat, is I go to robot container, I go to this K speed at 12 volts, I'll hit function F12, and we see to start that's at 3.92. And for starting, I don't really like running things that fast, so I'll change this to 1 meter per second. That's about 3 feet per second. That's much more controlled, much easier to test. Next thing I'll do is rotation speeds in rotations per second is 3/4. That's how fast the robot can turn. That seems fine for initial testing here. And then if we kind of read through the rest of this, I won't get into what most of this is doing. So much as we have a field-centric drive object right here. And I like to change this from open loop voltage to velocity. I find that to be a little more intuitive for making speed adjustments than open loop voltage. Don't worry too much about this if you have no idea what I'm talking about. Now, if we scroll down here, we'll find this configure bindings function. And this is where we set up all of our button bindings for a driver and operator. We see the drivetrain by default will do this here, where it's going to do this field-centric drive with velocity X. Velocity X is forward, backward on the robot. And it's saying we're going to look at the driver joystick, the left stick Y. So I've got a controller here, and left stick Y, this is the right stick, this is the left stick. See, this direction, up, down, is the Y. It's a little confusing because we have velocity X, but we're looking at the left stick Y. Again, velocity X here is the forward backward of the robot, and we're using the physical up down on the left stick on the controller to drive the robot. Side to side on the robot is velocity Y, that's left and right, and we're getting the left and right direction on this joystick. And for rotation, clockwise and counterclockwise, we're getting this stick here, this right stick. Then we have a few other buttons here. We see joystick A. What's it going to do? It's going to, when we press that, apply this brake request. Swerve request brake. If I hover over that, it's going to move all those wheels so they're in like an X stance so that the robot is kind of locked in position. The other button to know about is this left bumper. When we press that button there, which is this upper button right here, we can point the robot where it needs to point, press that button, and now that'll reseed which direction forward is. So with all that done, what I'm going to do is hit Control-Shift-P, and I'm going to deploy my code and see if it actually deploys. I see my robot's still on. Build successful. Real log pops up. That all looks good. Chirp chirp on the robot. If I go to my driver station, I see comms, I see code, I don't see joysticks. Let me fix that. Plug in there. See 1, move that to 0. Cool, now I have joysticks. And let's see if this actually drives. Okay, I'll enable the robot. And I'll push forward on the sticks. We see the wheels do point forward. And if I gently feel, I can feel the robot is indeed going forward. If I pull back on the stick, I can feel the wheels are rotating the opposite way, so that's good. If I push left on the stick, see my wheels all turned. If I gently push on that stick, that looks good. If I go to the right, robot's moving right, good. Let's try clockwise and counterclockwise next. That's clockwise. That's counterclockwise. So that all looks good. Okay, I think the final thing left to do is to put it on the ground and actually try it for real. So I'll click enable on my driver station and I'll push forward. See robots moving forward, pull back, backwards. I'll go to the left next. Good. I'll go to the right. Good. Clockwise. Good. Counterclockwise. Good. And just like that, I think we're basically good to go. It's spinning a little fast, so I could change that. But yeah, this is basically everything you would ever want in a Swerve drive. But yeah, this is working great. And I really didn't have to do any complicated Swerve programming myself. The generator took care of all of that, which was awesome. I'll click disable. So the last thing I want to share with you is that once you've done this Swerve generation, you're about 70% of the way to running something like Path Planner, which is super cool. And I say that because CTRE has a repository of example codes. This is on the repo, Phoenix 6 examples. You can see under Java, they have a project called Swerve with Path Planner and Swerve with Choreo. So what I've done is I've downloaded the Swerve with Path Planner example, and I've merged that kind of into my code base. It also makes a few changes to command Swerve drivetrain. It adds in this Path Planner builder. And the one thing you should definitely change here is their example has some really bad PID gains for following the path. And from some brief testing, I found that if I've dropped these to 1, I get some decent looking results. Then inside Path Planner, what you need to do is make sure that your Swerve modules are at the correct locations, you have the correct motors selected, and that your robot mass and bumper size are fairly close to what your actual robot is. After that, what I did is I made this simple test path that simply drives forward and rotates 90, and that'll give me a good idea on if this is working correctly. I then made sure I told it to follow that path. And once that's all done, I make sure I deploy our code. So we'll give that a shot. Build successful. And what we should see on the driver station is if we open up a dashboard here, you should see this auto mode chooser. I'll select this test auto. I'll go back to the driver station. And since I sketched it on the blue side, I'll make sure I select blue to make sure everything runs correctly. I'll select autonomous. And when I press enable, the robot should do what we designed it to do in the path. So I'll move out of the way here and move the robot, and you can see what that looks like. Okay, so I'm at my driver station here. I'll make sure I select autonomous, and I'll click enable. And what I'll do is I'll just have my hand hovering above spacebar to quickly disable it if needed. All right, here we go. 3, 2, 1. Okay. That's a simple path, but we saw it move forward and turn, which is everything we designed it to do in Path Planner. Now, while this isn't a full Path Planner tutorial, I wanted to show you that because if you're using the CTRE Swerve Generator, you get this functionality basically for free with zero extra setup. If you have any questions, feel free to drop them in the comments below and I'll see what I can answer. Till then, take care.